Welcome to solverfy.
So here we have a diagram of the system here, and we can say that a changing force on a changing mass would be equal to the gravitational constant times the mass divided by x squared plus r squared according to the diagram times a change in mass. We can find the horizontal component and say that df dm sub x would be equal to gm cosine of theta divided by, again, x squared plus r squared times a change in mass, dm. At this point, we can say that df of dm and then sub x is going to equal the gravitational constant times the mass divided by x squared plus r squared, and then according to the diagram, we can say cosine of theta is going to be equal to x divided by the square root of x squared plus r squared. And so we can say, again, times dm, so we can say that df dm to the x is again equaling gmx divided by x squared plus r squared to the 3/2 power times, again, dm. And we can finally say that if we want to integrate, we can say that df of x equals gmx dm divided by x squared plus r squared to the 3/2 power. And now we can integrate and say df of x. And then here we're going to integrate the other side and say gm. And then at that point, we can simply solve the integration and say that the force, the horizontal force, is going to be equal to the gravitational constant times the large mass times the second mass times x divided by x squared plus r squared quantity to the 3/2 power. And the direction would be inwards towards center of ring. So this would be our final answer. That is the end of the solution. Thank you for watching.